Yep.
Yep. Listo, entonces inicia. Entonces, usualmente Julián da unos mensajes. Voy a decir 5, 4, 3, 2, 1 para empezar la transmisión en YouTube. Entonces, adelante, Julián.
Ya estamos en vivo. Puedes comenzar, Claudia.
Okay. Hello, everybody, and welcome to our monthly seminar, a joint seminar of WinEED, Women for Environmental Economics Development Collaborative from Environment from Development Initiative. We are in the Colombian Center for EFD, and also the LAERE seminar from the Latin American Environmental and Resource Economics Association. So I would like to welcome you all today to our seminar. We have today Jessica Coria, who is going to talk to us about the effect of EU chemical regulation. Is there a chemical green paradox? So a bit of Jessica. Jessica is an associate professor in the Department of Economics at University of Gothenburg in Sweden. So her main research interest is the optimal design of environmental policy. So for that purpose, she does both theoretical and applied work. So most of her work is within modeling of environmental regulation. So we will be listening today a bit of this EU chemical regulation. Just a note before we start this exciting seminar is, well, all of you who are online, you are very welcome to join the association, the Latin American Association. If you are not yet a member, just take the advantage. We have a free membership for this year until December. It's a free membership, so go to the webpage and you can sign for free. And also there are a lot of interesting activities and things from the WinEED in Colombia. So you are very welcome to look at that. Okay, without more to say here, Jessica, welcome. You have, we will do the first 15 minutes with no questions, so Jessica can progress a bit on the presentation, and then please feel free to raise your hand or write your comments or your question in the chat, okay? So Jessica, the floor is yours.
Okay, thank you so much. So I open my presentation and I just do it full screen. Yes, there. So this is ongoing work together with Olof Johansson Stenman at the University of Gothenburg. And I mean, I imagine that, of course, many of you know a lot about climate change and kind of major topics in economics. Chemical regulation is one of those topics where environmental economists have not been so active. So a few years ago, I joined a Center for the Regulation of Chemicals, and through collaboration with natural scientists, I have learned a lot about regulation. And this paper is a sort of attempt to try to explain how regulation works in economic terms and the type of incentive it generates. And I mean, again, as an introduction, chemicals are important, a bit unknown, but there are so many of them, and many of them are hazardous. For example, the European Environmental Agency in 2016 developed a report where they quantified that the amount of chemicals that are hazardous that are in production or use in Europe is quite substantial. 62% of the total volume of the chemicals in Europe are hazardous to human health, for example. And the World Health Organization came up with some sort of study trying to kind of calculate the burden of disease connected to this exposure to chemicals. And it is significant. It accounts for 1.6 million lives and 45 million disability adjusted life years lost. And these numbers are just estimates that are based on those chemicals for which we have sufficient knowledge. But as we talk, there are chemicals that are being developed, products that are being patented, and more chemicals that are going into the environment. And unfortunately, we really know very little about them. So given the amount of chemicals that we have in the environment and the effect that they may cause, of course, it's important to regulate them. Europe has been a leader in the regulation of chemicals through national regulations by many countries, but in an effort to unify regulation, they implemented REACH, that stands for Registration, Evaluation, Authorization, and Restriction of Chemicals. REACH applies to all countries in the European Economic Area. And through REACH, different kind of steps in the process of bringing chemicals in the market are regulated. For example, through the registration process, firms that are going to produce or use chemicals in more than a certain amount must register this information with the European Chemical Agency and provide some information about the properties of the chemicals that are going to be produced or used. The evaluation part has to do with some sort of random check by the European Chemical Agency of this information delivered by firms. And then the two programs that are kind of the regulatory programs of REACH are the authorization program and the restriction program. And through these programs, we can have binding restrictions on the production or the use of chemicals. I'm going to talk about the authorization program. And this authorization program starts with the process of listing chemicals that are considered substances of very high concern. And these substances are not any, right? They are substances that are kind of nasty and they impose significant risk to human health and to the environment. They are classified as carcinogenic, mutagenic, or toxic to reproduction. They have persistent effects, bioaccumulative effects, or very persistent or very cumulative effects, or they raise equal level of concern as such property, for example, endocrine disruptor substances. So the idea of the candidate list is that chemicals are proposed to the list by countries or the European Chemical Agency, and they undergo a process through which at the end they end up being listed. And when that happens, then the firms that are producing or using the substance need to give information to their downstream user about the features of these kind of chemicals and the risk that they can pose on human health and the environment. So it is basically a disclosure program through which the one manufacturing or importing it or using it need to give information to the downstream users. And the candidate list also kind of triggers a process through which certain chemicals will be included in another list that is called the authorization list. And this list is a list including chemicals that might be subject to binding restrictions. These are the chemicals that are considered very hazardous, and then in order to be able to use them or produce them, then companies might need to require an authorization. And that's a process that is time-consuming. There is a certain level of uncertainty whether or not the firms are going to get authorization. And also it's monetary consuming because the type of information that needs to be delivered is not information that firms can provide easily. And then most likely they have to hire consultants. So this candidate list was introduced in 2008. And by the end of 2020, it had 303 substances included. this number is rather small if one considers that estimates of the number of substances that are hazardous are much larger. So the process is going quite slowly. But still, there are 303 substances included in the candidate list. And out of these substances, 86 have also ended up in this authorization list that requires authorization to be able to produce or use the chemical. And the purpose of the paper is twofold. It's to investigate the effects of the inclusion of this on the candidate list on the production of chemicals. And we do this theoretically, and then we test our hypothesis with data for Sweden. And the reason why with data for Sweden is that first, I mean, Sweden has one of the best registries that are available with information is public. Even though, I mean, Sweden is a small economy, still is it's a country that has a lot of exports of chemicals. So the question that we try to pose is like, has the production been reduced after the inclusion on the candidate list? And I can anticipate that the answer is a bit mixed. Yes, for most of the chemicals, but for some of the chemicals, we see an increase in the production right after inclusion on the candidate list. And we rationalize this increase as a response to the underlying uncertainty concerning the availability of the chemical in the future, given that it can be put forward for inclusion in the authorization list, and then binding restriction might apply to the chemical. So that kind of answered the question why the policy should have an effect. This candidate list is some sort of combination of two types of policies. First, there is an information disclosure policy where properties of the substances that are included in products are disclosed, as well as information about the type of risks that are embedded and measures that might be needed to take to reduce those risks. As well as there is a potential ban, a probabilistic ban that might imply that the chemical is not available in the future, and then firms might want to react to that, for example, storing chemicals. There might be other channels through which this list could affect production, and one of them is, of course, a reputational effect. REACH concerns the regulation of chemicals that are of the industrial type. For example, paintings or kind of substances that are used in the type of things that you are having in your desk, for example, cell phones and so on. So of course, for example, you think about a big company like in Sweden, IKEA. If a substance is included in the candidate list and IKEA is using it, and the downstream kind of chain implies that someone can know, IKEA might have a reputational effect and be connected to kind of some dangerous substance, and they might not want to do that because the reputation is so important that they want to anticipate this kind of effects and terminate relationship with any kind of producer using these substances. But this reputational effect it's not in the scope of this paper. Yes, so I think I don't know if 15 minutes have passed, but now I'm going to start with a model that kind of gives intuition of the type of effects that we expected to see. I think if anyone has a question, that would be a good moment, natural break to answer it. And there's no question, right? Only Jorge that is telling us.
Yes,
that
right,
we use the chat.
Jessica. There is no question so far. Yes,
okay.
but people can raise your hand or please send the questions to the chat. Go ahead, please.
Yeah. Or just interrupt me because probably I will not see you when you are in the in the chat. So basically, to be able to model the effects of the candidate list, we have a model where we have a final consumer and two types of firms. And these two types of firms are price takers. They are competitive firms. One of them is a chemical producing firm, and the other one is a firm producing a final good that uses a chemical in the production of the good that the consumers are interested in. And this chemical might pose negative effects on human health or the environment. And the consumer is unaware of the potential effects of the chemicals that are used in the production of this consumer good. This is kind of reasonable assumption. As I mentioned, this is like the paintings that we have in I don't know, the desk and so forth. So, I mean, we don't really know what is being used in the type of product that we are buying, right? And the kind of negative properties that might have. So these two firms might potentially produce over 2 periods that we denote 1 or 2. And this producing firm, the one producing the consumer good, it has the possibility to store the chemical at a per unit cost S. So if we start with the problem of the consumer, it's a typical problem of maximizing utility, where the utility is given by the utility connected to the consumption of the good that is used in the chemical, that is represented by the first term in the maximization, and another good for which we assume a price equal to 1. So such utility is maximized subject to the budget restriction, as you can see, the key feature of the problem here is that there is a term 1 minus theta t that is representing the effect of the knowledge of the adverse properties of the chemical on the valuation of the good, right? So the larger theta t is, the larger is the this utility that this consumer faces of knowing that the chemical might be hazardous, and then the less interested he or she would be in buying the good. So given this maximization problem, we can derive the demand for this good consumer final good as a function of the prices and income. And then we can solve the problem of the consumer good producing firm, where we assume a production function that has a decreasing return scale, where there is an input that is the chemical denoted by C. And this firm, as mentioned, is price taker, so buys the chemical at a price PC or PTC. And then given the condition that the marginal cost is equal to the price, we can find the supply of this final good as a function of the price of the chemical and the parameters of the production function. And then we just need to solve the problem of the chemical producing firm. We assume a linear production function and find what's the price of the chemical, given that this firm is price taker. And we can solve finally for the production of the consumer good that is using the chemical. And given this, we can get back the amount of the chemical that is going to be used in each period as a function of the key parameters that will be the disclosure parameter and income, the cost of the chemical. And so if we would assume that there is no regulation, then we could simply assume that no disclosure, there is no way this consumer will know something about the properties of the chemical. Theta 1 will be 0, theta 2 will be 0, and we could get the profits that this firm that is producing the consumer good would get. And then we can jump to the situation where we do have inclusion on the candidate list, and we can try to figure out what are kind of the effects that this might cause. And the fact that comes first is the disclosure. So there is a mass of consumers, and a share of them will get to know about the properties of these chemicals. We assume that share only gets to know, just simply because not all disclosure programs reach all the population. And then we can calculate what will happen then to the consumption of the chemical, given that now there is information about this theta, that this theta is not 0. And then for doing that, we can just simply calculate the consumption of the chemical when theta is positive versus when it was 0, no disclosure, and we compute the change in the consumption given disclosure. And you can see here that the change is negative. Of course, it will increase with the share of the consumers that get to know about the properties of the chemical, and it will also increase with the properties, the hazardous properties of the chemical, that is to say, when theta is larger, then the reduction in the consumption is larger, right? So it's intuitive. We should expect a larger reduction in consumption for those chemicals that have very large adverse effect. Then the second effect is storage. So as I mentioned, given that the chemical is added in the candidate list, there might be a probability that the chemical will be forbidden in the second period. So the problem is that if the chemical is banned, the firm that is producing the final good can only use the chemical that was stored to produce the final good, right? So the production will be limited to the amount that is safe, that is denoted C1S. And then given the cost of production and storage, we can represent the profits of this firm producing the consumer good. And then, of course, I mean, there is also a possibility that the chemical is not banned, and in such a case, it's business as usual. The only thing that would be is that the storage is given, right? It's just it's sunk in a way. So then what we try to do here is just to optimize what is the optimal amount that this firm will save of the chemical. And for doing that, we just maximize the expected profit. That will be the weighted sum of the profits when there is a ban versus when there is not ban. And then we do so, and we come up with the expression that is here. And this store amount will depend on the probability that the chemical gets banned, and it's also depending on the disclosure effect. And this is interesting, right? Because I mean, given that there is a disclosure, the demand for the chemical next period is not going to be as large as it used to be. And this, of course, should affect the incentive to store the chemical. So basically, one could assume the storage effect would be only that when theta and lambda are 0, right? While here we have the combined effect. So if we differentiate this expression with respect to the probability that the chemical is banned, we see that the storage increases when we assume or we have more certainty that the chemical will be banned, and this is kind of reasonable. So if we know that we will not have the chemical in the future, then we will have large incentive to store it today. So basically, if we now calculate the total consumption of the chemical, and this is like the chemical for use in the period 1 plus the storage, then we can see the full expression and the effect of the inclusion on the candidate list on the consumption and therefore on the production of the chemical. So then we see here that is affected by these two channels, the disclosure effect and the storage effect. And I think there might be many interpretations of this, but one of them is like disclosure effect loses effectiveness because of the storage effect, right? If there was not this threat that the chemical would end up in the authorization list, maybe we could have expect a larger reduction of the chemical consumption and production due to the disclosure. We can alternatively think that thanks to the disclosure, there is not so much kind of storage of the chemical in anticipation to the regulation. But in any case, these are two countervailing challenges that imply that consumption might decrease or might increase directly after inclusion on the candidate list. And so far, the analysis is kind of disregarding substitution. And we do so because, I mean, substitution should affect the incentive to store. So it cannot really be disentangled from the storage effect. So we do it gradually in the paper. We start with the model without substitution, and then we introduce substitution. And substitution makes things more difficult in the sense that, there might be many combination of inputs that need to be considered to know what is optimal. But we assume a substitute that is some sort of drop drop out a chemical that has not negative effects on human health or on environment, or at least not no effects. And we assume that it's a perfect substitute in the production of the consumer good, but from the beginning was more expensive to produce with, otherwise it would have been the chemical chosen, right? And we have to kind of consider all the potential combinations of the stored chemical, the new chemical, and the fact that we have four kind of states of nature. One in which the chemical is banned and there is no substitute, one in that the chemical is banned and there is substitute, and one where the chemical is not banned and there is substitute, and when the chemical is not banned and there is not substitute, right? You can see all these cases, and then we can optimize with respect to the optimal storage, and again calculate the total consumption of the chemical, and then we find this effect now, where here the storage effect is affected by gamma, that is a probability that the substitute is available. And of course, if gamma is 0, we go back to the previous case. If gamma is 1, there is no incentive really to store, or this incentive will be affected by the relative prices. So then we see that when we have substitute available, then we should expect that this storage effect is much modest, much reduced, and then we should possibly expect that the effect of the inclusion of the candidate list is a reduction in the consumption. So the idea of the model was to be able to develop some testable hypotheses concerning the type of direction or the effects on the consumption of the chemical. And then we have 4 hypotheses that we will try to test empirically, and they have to do with the effects of the parameter theta and alpha. Both of them have the effect of increasing the strength of the disclosure effect, and therefore reducing the consumption and the production of chemicals, versus the effect of increasing the probability of being included in the candidate list, that has the effect of increasing consumption, and versus the effect of the substitution, that is also affecting the consumption in a negative way. So this is where what we want to test empirically. And for doing so, we collected information about the substances that have been included in the candidate list and the production in Sweden. And now the process through which substances are included in the candidate list is quite cumbersome. It's a lot of political economy embedded in it. To be included in the candidate list, one needs to be proposed, and European Union member countries can do so, or the European Commission through ECA. And when a substance is proposed, a dossier needs to be submitted, and this dossier will report the properties of the chemical that motivate inclusion in the candidate list. And after that, a 40-day consultation process starts, where every stakeholder that wants to participate and comment on the inclusion on the candidate list can do it. And after that, the member state committee, that is a body where each country has a representative, can agree on the identification of the substance as a substance of very high concern, and this decision is ratified later on by the European Commission. Now, when those substances are included in the candidate list, then there will be a prioritization process to be added to the authorization list, and this is said to be dependent on these persistent properties of the chemicals, as well as wide dispersed use and high volume. So in principle, we really should be kind of regulating with restriction those that are widely used, that are quite persistent and can have long-lasting effects. So one can wonder, okay, but how one can do this? Because of course, we know that were added to the candidate list in a certain year, and then we can compare the production before and after, right? But we are not talking about any chemical. We are talking about very hazardous chemical. And in general, we would expect that my knowledge still exists to some extent, and these chemicals might have already followed a trend downwards. So we would like to have some sort of sample of chemicals that are kind of similar in a way, that we could try to use to have some sort of counterfactual. And here we were lucky because there is a NGO, ChemSec, the Chemical Secretariat, that has kind of come up with the mission and the idea of develop the unknown list, the SIN list, substituted now. And this SIN list is basically using the criteria that is established in the REACH regulation for inclusion in the candidate list, screening all the chemicals that are available or in use in Europe and see which one of them should be listed. So this is very much a technical list that is avoiding all the political roadblocks of this process of listing that is connected to the regulation. So it's a very technical list, and in principle, it's supposed to be some sort of signal that helps some stakeholder to anticipate which chemical might end up in the candidate list, but it's just a voluntary list. It has no kind of regulatory feature behind it. So we use this list as our kind of guide to build a sample of chemicals. So we take the chemicals that are included in this list, as some of them are going to be included in the candidate list, and some of them will not. And that will be our control group. And now I can tell you, I have been doing research on chemicals now for a couple of years or 3 years at least around these topics. And so I have many ongoing papers. And in one of them, that is being revised now, we try to understand what drives the regulation of chemicals in Europe. So we take the full sample of chemicals that are being used or produced in Europe, and we try to understand which properties of the chemicals are the ones that explain that certain chemicals, just certain chemicals, end up being listed in the candidate list. And we do this for the full sample of chemicals in Europe, but also we do it for different lists, and one of them is the SIN list. And unlike the candidate list, the SIN list includes almost 1,000 chemicals. So I have worked with natural scientists and a professor in mathematics to collect information on the toxicological properties of these chemicals. So we have been able to develop certain scores that tell how dangerous they are to human health, which is measured by the CMR score that stands for cancerogenic, mutagenic, and toxic reproduction, and environmental score that kind of account for the negative properties on the environment due to persistency and long-lasting toxicity. And then we were also able to kind of collect information about the scientific knowledge that is available about these chemicals by screening all the scientific publication over the last 20 years that have been publishing information or studies on the negative effects of the chemicals. So we collected all this information, and through machine learning, we were able to match the studies to chemicals being studied, and we were able to produce a count, a publication rank that tell us, I mean, how much we know on the different chemicals being listed. And then here I'm just showing you a plot that concerns one of the figures in one of those papers, where what we do is just simply a regression, a logistic regression analysis, where we look into what drives the regulation of the chemicals in Europe. And we really see that, I mean, that the major difference, for example, when it comes to the chemicals with regards to the SIN list, had to do with the economic variables. The ones in the candidate list are producing much lower volumes and by larger number of countries. But still, we find that the scene list is a very good counterfactual for the chemicals being regulated in the candidate list when we look at the European regulation. Now, we need to connect this to the Swedish regulation, and that might be a bit different. So to collect information, we make use of the ChemiStat database that contains information on production and import. Recall that here we are talking about chemicals that are being used to produce goods, right? So they are inputs. So we unfortunately just have information on the sum of them, as well as on the number of articles that are using the chemicals. And we have information for the period 92-2019, though we use all information from 2000 to 2019, given the amount of noise in the first period. And not all the chemicals being listed in the candidate list or in the scene list are being produced in Sweden, but we are able to match information for 325 substances, and of those 112 are included on the candidate list. And then we have information on many things. When was the year when they were included on the candidate list, whether or not they are included in the authorization list, if they are affected by other regulations, in particular the other program that is a kind of mandatory or mandatory regulation in REACH, that is a restriction program, and so forth. I also make use of all the information that I collected through my collaboration with other disciplines to be able to kind of have proxies for the adverse effect of the chemicals, as well as the available knowledge. And here it's the data that we use in our analysis. And then we have, as I said, 125 chemicals that are included in the candidate list and 200 that are not included. And then there are different kind of variables that are kind of showing that there are differences between the chemicals that are listed in the candidate list and in the scene list in Sweden, which is maybe not surprising because Sweden has been a kind of leader in environmental regulation, and it has been also a leader in terms of the chemical regulation. So when it comes to the candidate list, the chemicals that are there are being more hazardous than our control. But on the other hand, even if we acknowledge that that's the case, it's also kind of important to recall that here the regulation is implemented at the European level. So Sweden is a price taker in terms of regulation. Yes. So here in this plot, I want to show a bit of like what's happening to our sample and our control before and after kind of the treatment, right? And our control is also in a way treated because there is a list that is the same list, and these chemicals were included in the same list at some point. But you see that those chemicals being included only in this same list, you can see that the before and after distribution is pretty much the same. We do a test and there is no difference. But it's not the same for the ones that are treated. And then for the ones that are treated, we can separate between those that are only treated in the candidate list, that are only subject to disclosure, versus those that also are now in the authorization list and they are binding the restriction that apply to them. And then I think the most interesting case is this one, because you see that the distribution cannot becomes wider. So the median will be reduced, but there are increases in some substances that imply the distribution kind of widens. So here we really see statistically that there is a difference between the distribution before and after. And then when it comes to the ones treated also on the authorization list, we don't really see a statistical difference when it comes to our test. Yeah, there is a decrease in the median, but the distribution are not statistically different. So this is kind of an interesting group. So then we want to try to explore it. What is happening here? Why are certain substances being kind of increased in production after inclusion, which seems kind of counterintuitive, right?
Yeah.
So then,
hi, sorry, one question, Natalie here.
Please
Regarding
go ahead.
regarding the previous graph in the candidate list, is that like internal production, or it also considers production overseas? Because you said you have a data set on
Production
imports,
and imports.
right?
Hmm?
Oh, okay.
Yeah,
so
but yeah, it's imports to Sweden, right? So it will be production, Swedish production plus the imports that are for use
perfect.
in Sweden.
Okay.
Hmm?
Thank you.
Yes, so in this plot, what we do is that we look into the chemicals that are added to the candidate list, and we try to see in 1 year or 2 years window around the date of inclusion on the candidate list, what happened to production, right? So you can expect here's like number of times that production is changing. So if production is being decreased, one should expect that the change holds from 0 to -1, right? And if production is increased, it will go from 0 to positive numbers. And then you can see that in a year window, we have a significant number of chemicals that have production that is decreased. But interestingly, we have also a fraction of them that are kind of increasing, right? You see it in the right-hand side. And we look into the window that is 2 years before and after inclusion, and we see the same, though of course the adjustment time is longer, and then we can see that it's a larger number of chemicals for which production is reduced. So then we try to analyze this a bit more, and then we do a probability analysis of the chemical, actually it's a logic analysis of the chemical for which the production increases after the inclusion on the candidate list, and we try to see what drives this increase. And this here it's the odds ratio. So the variables that affect negatively the probability will be in the left-hand side, and will have coefficient less than 1, and the opposite hold for the other. And we also present the intervals of confidence, and we can see that the only 2 variables that are significant here are the CMR effects. When the chemical have CMR effects, then it's much less likely that there will be increases after inclusion on the candidate list. And the other one is our publication rank that tells us whether or not there is a lot of knowledge about the chemicals, and this is also marginally significant, but still significant. It tells us that when chemicals have very well-documented effect, then there is more likely that they will not have increases in production after inclusion on the candidate list. So far, I mean, the evidence that I have presented kind of tells that, yes, it seems to be an effect, but on the other hand, there is a counterfacting or a countervailing effect in the direction of like having some increases, and these increases seem not to happen when the parameters connected to disclosure are significant, right? But to study this question more formally, what we do is we estimate diff and diff, a staggered diff and diff of the form the one presented in equation 1, where we regress the logarithm of the production in year T for a chemical I as a function of fixed effects of this chemical, temporal effects, and the inclusion on the candidate list, where this it's a dummy that will take values equal to 1 for years for chemicals included in the candidate list for years where the chemical is included in the list and 0 otherwise, right? And then we do this for the chemicals that had been included in the candidate list, but then of course we have a subgroup that has also been included on the authorization list. So for this group, we can also kind of analyze the effect of the inclusion on the authorization list, right? So here we have as a sample our 325 chemicals, and we are trying to identify the effect of the treatment for these 125, while here we have the 125 chemicals that have been added to the candidate list, and we try to see the effect of inclusion on the authorization list for those chemicals that had been added to the authorization list. So I want to present the results as figures, and then I mean, so we unfortunately, many of these proxies that we have for how dangerous chemicals are or how much knowledge it is, it's cross-sectional. So we cannot really use it in this diff and diff, right? They will not be varying temporally. So we try to take subsamples and see whether or not we find that the results follow certain logic according to what we would have expected. So if we take the full sample of the chemicals, we see that there is an effect of the inclusion on the candidate list that is significant, but then we start kind of taking away observation. We take away those chemicals that have been subject to other chemical regulation by the European Union, particularly the restriction list, that is also kind of a list that might impose certain binding restriction, and then significant slight decreasing substantially. And then we take away those chemicals that had been added to the authorization list. So we just focus on those that I show you in the plot that had the widening in the production, right? And then we see that the effect, the statistical significance of the effect disappears. Then we try to look into the effect of disclosure. So we take these estimates of the properties of the chemicals in terms of the CMR score, the proxy for how hazardous they are connected to cancerogenic, mutagenic, or toxic reproduction effects, as well as the scientific studies available. And we divide the sample in those that have more than the median and less than the median. For both cases, and we focus on those, for example, those chemicals that have an effect that is less hazardous than the median. So then, I mean, we don't expect these theta parameters to be so large, and then we find that the effect is negative but statistically insignificant. And the same will happen for studies that are not for those chemicals for which there is not a lot of knowledge. And then we try to proxy for substitution. And substitution is one of those things that are very difficult when it comes to chemicals, because, I mean, it's not evident what can be used to substitute for another chemical. I mean, there is some, or there have been some attempts by some chemical structure, but it's not evident that this would be the case. And even if it's the case, of course, I mean, one thing is technical substitutability, but then it's the question of to what extent functionality or economic substitutability will be also kind of making the change feasible. So to be able to kind of come up with proxies, we came up with kind of two strategies. First, when a firm has a chemical that has been added to the authorization list and wants to keep using it, it needs to request authorization. And this authorization process is tricky. It's really cumbersome, and this firm will have to show that the chemical has more benefits of continued use than cost, that they are not substitute available, and so forth. So if one goes through the process and on top of that one is granted authorization, then one can assume that they are not substitutes. But if one is not granted authorization, then, I mean, they were not comparing arguments that there are not possibilities to substitute, right? So we take away those chemicals from our sample that where we know that that substitution was not possible, which implies that now we have possibility to substitute. And then we also kind of divide
Jessica,
the
sorry
sample.
for interrupting you. Just 5 minutes, just to give the chance to have some questions, please.
Yep. Should be fine. I am about to come to them. And then we divide the sample in terms of the chemicals that are widely used or widely used in terms of the median, because, I mean, if they are widely used, they need to have some kind of functions that are be able to substitute because they have larger markets. And then we find the result in the direction that we expected. Those chemicals have an effect that is statistically significant in line with our theoretical model. We do the same for the authorization list. We had anticipation that the coefficient of the authorization list should be lower than the coefficient of the candidate list, given that here storage is more predominant, given that now the chemicals are actually going to be subject to binding restriction. And we do confirm that in principle, and the results for the rest remain the same. And then we try to see the kind of typical things. I mean, are the effects like temporarily varying? When do the effects happen? Do we have lags and leads that can kind of imply that the effects are not happening contemporaneously? And then here we use the full sample and as well as the sample that is not included in the authorization list, and we see that if the candidate list has an effect, usually it has it 2 to 3 years after, right? This is when the effect it's like statistically significant. So there is an adjustment, and then the effect of the list becomes more significant around year 2 and 3. And this holds for the 2 samples. And then we try to see, doesn't matter when this chemical was listed, because of course, if listed at the beginning, one could anticipate that the effect was quite large, because simply this policy was new, everyone was a bit uncertain, and of course, no one wanted to end up in problems. Then they reacted quite a lot to the regulation, and we can observe that at the beginning there was quite an effect of the first chemical listed. Though of course, I mean, these chemicals listed the first might also be very hazardous, and these effects are quite significant for some specific years, which tell us something about kind of the specificities of the problem, right? Some chemicals, this is not something that's generalizable. Chemicals are very different, and of course, some of them might have more possibility to substitute and more or effects that are deemed more hazardous, and then there might be a different reaction. So now I'm coming to the end. So what the paper tries to do is try to formalize the different channels through which the European chemical regulation has affected chemical production. We find that there is a disclosure effect that reduces demand and therefore production of chemicals. We find that there is an effect that is against this disclosure, that is this stock building to mitigate the risk of not having the chemical available in the future. And then we also find that this effect, the incentive to build up stocks, are reduced by the availability of substitutes. But at the same time, as long as there is no binding restrictions, there are not really incentive to phase out the use of the chemicals. And firms will try to keep using the chemicals as long as they can. From the theoretical, from the empirical side, we do find that there is an effect of the candidate list on chemicals in the direction that we expected. That there is a reduction, particularly for those chemicals that are subject to binding restrictions. The first. So we do interpret this as an effect of the disclosure effect that was pretty much predominant, particularly at the beginning. And also our results kind of highlight the relevance of substitution. If we take a very conservative kind of approach for those chemicals, we do find reductions that are around 40%. Thank you.
Thank you, Jessica. Very great presentation and very interesting topic. Thanks. I have the pleasure to lead the discussion. So first, this is a very important topic, and this is very new, especially for environmental economists. Jessica has been leading the topic. So please, Viviana, if you have a question, just please go ahead.
Well, I was clapping, but thank you very much, Jessica, for your presentation. So yeah, I had some questions in mind. So perhaps I can start with two. So the first question that I have in mind is about the industry where these chemicals are used. So I don't know if you can identify, for example, if there are some chemicals used in agriculture or some other chemicals used in other industries, or you are focusing on any particular sector. So I missed that perhaps. And the second question I have is that, I think that like what you talk about the substitution is really interesting. And I think that is also super difficult to measure. So I was thinking, I don't know if if there is any way to measure this substitution also, not with other chemicals, but for example, with different practices or like the introduction of different, machinery that substitutes for the chemical, for example. So these are the two questions I have. Thank you.
Thank you. Yeah, I mean, REACH, it's about industrial chemicals. So there are other kind of European regulations that are dealing with chemicals that are more specific, like those connected to agriculture, like biocides and pesticides, and as well as the one connected, for example, to pharmaceuticals. and each single regulation is based on different kind of principles. So pesticides, more like an authorization process that is very much connected to scientific expertise, right? So you would expect that the process is a bit different. Now, the industries that are kind of using these chemicals are pretty much many. Manufacturing of products, mining, transport, it's a large variety. Of course, some of them might be more connected to the consumer, but I'm not sure if we will be able to kind of identify the effect by kind of going into the very much details. We can identify it. We have collected lately some data on the number of industrial sectors that are using the chemical. We have not run the results again with that kind of variable, but we will do to try to see those chemicals that are used for by a larger number of kind of sectors have a different pattern. But we had this idea of trying to search for some sectors that were more like consumer driven, but it's not so evident, right? I mean, and many of these products are used anyhow by consumers, right? And the consumer will not know in the absence of some disclosure, and still the disclosure probably mostly affect companies, right? Like IKEA, as I mentioned, that will not want to be kind of connected to chemicals that might have a negative effect on the consumers. Your second question was about substitution. And again, this is not easy. I have kind of colleagues trying to, again, using a chemical extract to anticipate what kind of chemicals will have more kind of substitutes, but it's really per se a topic. And I think I have been attempts by organizations. There is a sort of substitution center here in Sweden just with the purpose of promoting substitution. But it's not like they can come with like general recipes. It's really like a process one by one. The firms need to kind of state what is kind of the purpose, and then you kind of evaluate the substitution possibilities given the manufacturing process and so on. So it's really firm specific, product specific, technology specific. So it's really very difficult to draw general conclusions.
Thank you very much. Yeah, thanks.
Thanks, Jessica. I don't know if someone else have an extra question, please.
I have a question.
So please.
Hi, Jessica. Thank you for that insightful presentation. So I guess my question is related to the first point that you were saying. I have questions regarding the ban itself, because it's a ban on production, which of course generates the incentives on the storage effect, right? But at the same time, I guess the European Union has incentives to curtail production, because if they restrict use, I'm assuming firms can find a way, to maybe export that somewhere else. I was just trying to understand the economics behind. But then related to that point, I wonder, what's the role of final consumption there? Because if I understood well, the process of what it means to be part of the candidate list is that firms need to disclosure to people, I guess, that is downstream, right? The production. Is it that I understood it well, or is it the authorization list? And then I was wondering, just to finish. So I'm assuming, without having any knowledge on these chemicals, that some of these chemicals may have harmful effects on health or the environment when they are produced, and then some others maybe when they are used. Like I'm confused with that part, because you were giving the example, for instance, of a painting that is in a furniture from IKEA, right? So if there is any toxicity out of that specific painting, it will be present even if I use whenever I use the furniture, right? Which makes me think that it would be smarter to ban use of that painting. Therefore, there won't be incentives to storage and so on. But if the harmful effects come out of producing the painting with a specific chemical, then it makes sense, right? What the EU is doing. So again, this question is because I have no knowledge on chemicals. I was just trying to understand whether there are differences in which like production step or that chemical or like the whole, you know, process of producing and using the chemical, if there are differences in the harmful effects that this may
yeah,
generate.
so I mean, in general, of course, it's kind of a general rule that you regulate closer to the point where the damage occurs, right? Now, these are hazardous chemicals, right? Hazardousness per se means that there are properties that are intrinsic properties to the chemicals that you can never fully anticipate, all kind of the circumstances under which there might be kind of a damage, right? So of course, I mean, they can be hazardous when you are manufacturing or painting, and then you just simply need to have the proper equipment, right? And that's kind of a measure that can be easily taken. But then you have children that chew on kind of furniture, and then the effect happens then. There's enormous amount of kind of things preventing chewing of children, right? Many painting things and so on. So so this is why, I mean, the regulation, it's happening at the high point, is because the hazardous properties imply that it's very difficult to anticipate all the kind of potential cases where there will be a damage. Yeah, I think that partially kind of answers your question, right? In general, when we want to regulate, it's like a risk. We want to minimize risk, but hazardousness is like you have a bottle with something that is so hazardous that you have no way to be sure that that will be never kind of come to the environment.
But then, if okay, that's the rationale behind the fact that there is this possibility of storage in the chemical. Is that like fitting into the idea of an incomplete regulation, basically? Like, I mean,
no, but think about it. I mean, think about hazardous pesticides, right? I mean, like DDT and so on, that had been banned in many countries. So you can ban production, and maybe it's easier to control. To ban use, it's very difficult. How will you monitor it?
I see.
You know, they are kind of. This is a problem in the developing countries, right? There are places in the world where there is such an amount of chemical kind of stored that are hazardous, and it's not possible to even treat them because, I mean, it's incredibly costly. They had been stored because they were effective. I mean, you could not really regulate the use. They are still being used in some countries. How are you going to kind of monitor that? It's easier to kind of go to high in the production chain, because then it's easier to know which are the polluters, right?
I guess I was
That's
thinking
kind of a rationality for that.
Yeah, I was thinking about the regulation of lead in the US, right, in gasoline. So in that's a case in which you ban the use of the toxic.
But then the units that are kind of in charge of the use are refineries that are easy to regulate, right? Because you have still a number of them. They are not consumers where you have millions. That would be impossible, right?
No. I was just referring to the intermediate, like in your model, right? You have two companies, one that produces the input, which is the chemical, and the other company that uses the chemical. So I was thinking about the use, you know.
Yeah, of course. I mean, but then, so in principle, you can ban directly production and use, but then, I mean, the storage will happen in products instead, or directly on the chemical, but it will happen still.
Okay. Thank you.
Jessica, thank you. I have an extra question just to close the session and close the seminar. My question is I think that, do you think that the results are determined because this is Sweden, or because you know, you see that the environmental regulation in Sweden is very strict, you know, very stringent, and then perhaps in other European countries it's not like that. So do you think in other countries the results will be different, or are you planning to extend your research to other countries? I know that this is a challenge for you to collect information. This is actually a unique database.
Yeah, so I mean, I have collected data for the other Nordic countries, but it's the Nordic countries, right? So you could anticipate that you should not expect that to be so different to Sweden. I think, of course, I mean, where would you expect this to be different? It needs to be in countries in Europe that are less developed, right? And those are exactly the countries where the data is not available, which is a pity. So, but on the other hand, if you think about it, I mean, the results say that there are some effects, but they are for very few chemicals. It's like, still, you could expect that this list has much less effect in other countries. Absolutely. Absolutely.
Thank you very much, Jessica. It's a pleasure for us to meet you and have the chance to discuss the research with you. Thanks for leading this topic in environmental economics. So we are closing the session. Thank you very much. Have a nice day for everybody. Thank you very much. Thanks, Julian,
Thank you
for
all
helping
for
us with
the
all the organization.
comments and questions to everyone. Thank you.
Goodbye.
Okay, bye.